This is a typical set of stones that we would use for honing. This stone, as you can kind of see, has a fairly coarse stone, and this is what we use for roughing, and we'll get the size within a couple of thousandths. And we'll use a finer stone. This one actually happens to be a 220 grit, and we'll finish up with that, and then we'll go in with a brush so that we'll have a true plateau hone finish. As you can kind of hear, this cylinder is way out of round. And we're going to be taking about 25 thousandths out to get it to the size we want to go to. I've shut the hone down for a minute here, just so you can kind of see how bad this cylinder really is. The lighter spots, of course, are where we've actually honed, and you can see the darker spots where the cylinder is way out of round.
Introducing the first ever engineer-designed super finishing center, or SFC. In production since 1993, the SFC is designed specifically to hone or polish cylinders up to an RMA finish of 0, eliminating the concerns of taper or out of roundness. How does it accomplish this? The uniqueness of the SFC is its designed and patented CNC polishing system. Integrating the 12 stones into an automatic progression, this system will achieve the desired finishes in a computer-controlled environment with little or no operator supervision. 10 years of engineering, production, and qualification has allowed us to bring the SFC to the market with the ability to replace the conventional polishing processes with superior quality, accurate tolerances, operator equipment changeover, and all of this in lightning speed. Let us take you on a tour of the system. Setup is as easy as turning on a computer. Once the SFC is brought up, simply tell the computer the diameter and length you're going to use, and it takes it from there. Let's see how this works. The major factor of the SFC computer is its operator-friendly interface. The touchscreen operation eliminates keyboard errors and simplifies use. The programs are set up in blocks. Each block represents a selected number of passes at a particular stone set, pressure, and speed. The machine then moves to the next block and continues until an empty block is encountered, at which time it returns home and awaits operator action. There are buttons to send the machine to home position, send the slides to the center for stone maintenance, or to park the heads or slides for easy removal or insertion of the workpiece. To alter a program, head and tail positions can be captured by using the joystick to maneuver the heads to the desired position and then press a screen button to set that position in the program. Information is relayed to the operator screen to alert the operator of critical errors that could occur, which could cause a real crash to the system. Setups can be saved and recalled for later use on products of the same settings. Saved file names can be in plain English up to 256 characters. The SFC maintains records such as total machine hours and individual stone hours, as well as data occurrence logs. There is an engineering mode where individual parts of the machine can be operated for maintenance or test programs run. All machine parameters are accessible should fine-tuning be required in the future. These parameters are password protected to prevent unqualified personnel from entering values. Now let's see how the mechanical aspects of the SFC operate. The polishing stones are a main factor of the SFC. With stones available to polish most all materials, the capabilities of the SFC span the majority of the manufacturing and aerospace industry. The computer controls the amount of PSI and runtime to ensure the finish that is right for your particular application. The SFC is so precise that super finishing applications are available to clients who require mirror finishes of 0.02 microns. The automatic stone changeover is a patented process that uses air and hydraulics to move the stones from one location to another, eliminating the need for manual operator assistance. This alone is a substantial savings in turnaround, especially in a production atmosphere. The SFC's base is constructed of weldment and stress material which eliminates operation vibration and increases the life and durability of the equipment and offers years of dependable service in a production environment. The SFC has readily available components which makes this system maintenance friendly to any company. The SFC is available in both 2-meter and 4-meter widths and can be customized to meet the client's specifications. If superior quality finishes and operator-friendly technology are concerns of yours, the SFC could very well be the answer.
Okay, here we've got, this part's already been polished. This has all been sanded with 1200 grit with WD-40 as a wet sand. You can kind of see it's got a nice satin finish to it, but not much of a shine. That's how you use a bumping wheel.
What enables commercial and military aircraft landing gear to withstand repeated takeoffs and landings? What gives a race car the winning edge and makes your family car dependable and fuel efficient? And how do engineers ensure increased flexibility, movement, and durability of life-enhancing orthopedic implants? Every day, aerospace, automotive, medical, energy, recreation, and many more industries are giving it their best shot, improving product performance through shot peening technology. Shot peening is the most economical and practical method of combating fatigue failure in metal parts. Shot peening allows parts to handle higher stress levels, prevents stress corrosion cracking, enhances lubricating efficiency on load-bearing surfaces, enables substitution of lighter metal without sacrificing strength and durability, creates uniformly textured surfaces that promote adhesion of special coatings or that meet cosmetic requirements, forms and straightens metal parts while inducing beneficial compressive stresses in surface layers, closes porosity in castings and powdered metal components, and resists spreading and galling by the combined action of work hardening and compressive residual stress creation in mating surfaces. So, how does shot peening work? Simply put, it is a controlled process of making dents. The surface of a part is bombarded with small, spherical media called shot. Each piece of shot acts as a tiny peening hammer that creates a dent in the metal surface. In order for the dent to be created, the surrounding surface layers must yield and stretch. The non-yielded layers beneath the dent resist the stretching deformation and thereby create a residual compressive stress zone around the dent. Overlapping dents from multiple shot impacts develop a uniform layer of compressive stress. External loads and manufacturing processes like welding, grinding, and machining can cause tensile stress on a metal surface. Those tensile stresses attempt to stretch or pull apart the surface, which can lead to cracking and part failure. However, the compressive stress from shot peening will significantly delay or prevent crack formation in the compression zone. The deeper that stress layer, the more resistance to cracking. In fact, the residual compressive stress produced by shot peening displaces the tensile stresses that lead to fatigue failures. The net result? Compressive stresses induced by shot peening provide significant increases in component life. A growing list of companies are taking that fact to the bank. For example, the aerospace industry utilizes shot peening in the manufacturing, maintenance, and repair of aircraft components. Shot peening increases the integrity of aircraft parts and thereby increases the safety of everyone that flies. Leading manufacturers of automotive undercarriage products for street and racing vehicles use controlled shot peening to increase the fatigue life of springs, connecting rods, drive pinions, crankshafts, transmission gears, and much, much more. That sort of performance improvement is being designed into an ever-increasing variety of industrial, commercial, military, and consumer products. As demand grows for less weight, increased strength, and improved durability in high-performance components, more and more manufacturers are giving it their best shot. They're discovering the advantages of precisely controlled shot peening technology, delivering proven performance right where it's needed the most. Find out more by subscribing to the Shot Peener magazine, attending the next shot peening workshop sponsored by Electronics Incorporated, and visiting the only website dedicated to shot peening, www.shotpeener.com.